Hello everyone, I'm really happy to see you all here. And today we're going to talk about Java agents and how and why would you need to create one. My name is Oleg Shalaev and I come from Estonia, which is far, far away. And I work for Zero Turnaround, the company. So a word about myself, why should you hear and what I say and why should you trust me? I am a developer advocate currently at Zero Turnaround. Before that, I was a software developer for about 6 to 7 years, and then suddenly I felt an urge to help the community more, so I transitioned. And as a developer advocate, one of my main responsibilities is to talk to the community and try to make you work as efficiently and smart as possible. So one of my main responsibilities is to maintain the Rebel Labs blog, where we try to publish technical opinionated content. So if you would like to read articles about the technology, you are welcome to check that out. And one other effort I'm involved with is the virtual jog. So if you are members of a normal Java user group, you know that they create meetups and deliver content and sessions to you. So Virtual Jog is an online-only Java user group. So if you have one, if you don't have one in the vicinity, you can just join that. And twice a month, we try to deliver the best sessions and best speakers from the Java community to do presentations online. So you can enjoy that from the comfort of your own home. And if you have any questions or if you want to chat with me, the best way would be to ping me on Twitter. I go by @Shalaev. There, hopefully we'll talk. So a word about Zero Turnaround. There's a company that makes tools for Java developers. Currently we have two. One is JRebel, which is a tool that can reload classes in a running Java process, so you don't have to restart it all the time when you develop. So it boosts your productivity as a developer. And we have XRebel, which is a performance tool for developers doing Java web apps. So if you would check those out, my employer would be happy and they will send me to more conferences to talk to more awesome people. And I will be happy as well. So, and if you would like to join another conference, just the last announcement, the Virtual Jog, the online-only jog, runs the 24-hour straight conference on September 27th. So since you are at the conference here, maybe you would love to join the next one, and you can just go register, and all the videos will be streamed at YouTube. So you can. This is a week after Java 1, so when you feel that downside of not being at the conference, you can tune in and become happy again. So hopefully that would be great fun. So with all that said, let's talk about Java agents and the real reason why we all came here. So Java agent is a very powerful concept. And how many of you know what a Java agent is or have written one? Oh, quite many of you. So hopefully we'll cover the easy parts quickly and then try to go a little bit deeper. So a Java agent as a concept originated somewhere at Java 5. I guess they added that to the official API. And this is the thin layer that can sit between the JVM and your application. So it separates the application from the underlying platform and gives you a unique opportunity to be in the middle of all things. So this wonderful opportunity has created a chance to create very cool tools that use Java agents, and all those companies and the libraries and tools up there use a Java agent to do things that will not be able to do with just a library or a framework with a normal way how do you add code to your Java application. So from testing libraries to build tools to all kinds of profilers and APM tools to things like JRebel, and I'll talk a little bit how JRebel utilizes Java agents later to see the real power. So at first, I would like to start with a simple problem that maybe will get you into a mindset of what what you can do, or the problem that you cannot easily solve without a tool like a Java agent. So imagine you have a code in the application and you want to build a tracer. So for every method invocation, you want to log a statement when you enter the method body, and maybe you want to log the parameter values, and then when you exit the method, you want to also know that, oh, at this precise time we have exited the method, so you can get kind of like a representation of how your program works. So you want to build a tracer, and it's a fairly normal idea. It's a fairly useful tool that you might want to build at some point of time, and obviously there are since the problem is not that complicated or unique, there are solutions that build specifically stuff like that, a solution for that. So one of them is Byteman by JBoss, and this is a tool that allows you to specify rules declaratively for enhancing your Java code. So, and if you imagine that you have a Java app that looks like something like this, and you have like main method and multiple threads running, what you want to do maybe is to print stuff, and you want not change the code of your Java program, right? Because changing the code of the application that you're going to put in production to enable something, some small enhancement, might not be the best idea ever. Every line of code that slips into production contains possible bugs and can decrease the performance or whatnot. So you would like to avoid changing the actual code of your application. So what you would like to do, you would like to supply something from the side. You would like to, you cannot change the underlying platform. You run on a JVM, and your operations team would not be very happy if you say, oh, let's have this enhanced version of the JVM and run that. But what you want to do, you want to inject some logic from the side, and Byteman allows you to specify rules in a way like that, where you have a DSL that says, oh, do this when something happens, or do that when something happens. So this particular rule tells us that when the start method of the thread class is executed, then please trace that line. And this is kind of when you run your Java process with the Java agent of the Byteman, and it will run the application on top. And if you provide some parameters like that, you will exactly see that tracing being established. So you can use Byteman for simple tasks, but then at some point of time, you realize that you want to solve problems that the established tools or libraries have not yet touched, and you would like to express your creativity at how to solve various problems. So maybe, for example, you would like to dump every loaded class file into a certain folder to know what classes are exactly loaded, or something like this. And then you don't have the ready out-of-the-box solution to do that, and you will need to start writing Java agents for yourself. So, and the Java agent will allow you to do all of that. All the tools are, many tools use that approach, and they hide the actual, or sometimes hide the actual fact that they use Java agent underneath. But when you think about this, at every tool which uses Java at some point of time will execute the Java command, and they will run some class, and they will have the class pass and everything. So to enable a Java agent, and you just need to supply a Java agent parameter to your Java. And since Java 5, so like what, 15 years ago, you can do that. So if you are running more or less, well, not ancient, not super dead dinosaur version of Java, this is the possibility that you would need to, you might consider. So the configuration, that's simple, and this is why this approach has been so successfully used by many tools. If we look at what the Java agent consists of, there are a couple of things. So first of all, a Java agent is a program. It's a Java program which you write using Java language or other languages, but probably you would like to use plain Java. And obviously, a Java program consists of classes, and one of the main things that you will need in the Java agent inside the jar file is an agent class. An agent class should be a class just like normal main class of your application. Your entry point into the code is just any, there are no conventions how to name the class. You just need to follow the convention that it has to have the main method, that is the public static void main, which takes an array of strings as a parameter. And your agent class will have two methods like that. One of them is agent main, and one of them is a pre-main. So as the name specifies, the pre-main will be executed before the control flow will be given to the application classes. So you are, with the Java agent, you're creating this thin layer between the JVM and the actual program, and you will be given the control flow before the actual application. So, and the pre-main class of the Java agent will be executed. Then you will need to package this. To make use of a Java agent, it has to be packaged to the jar file, and you will have to provide a specific manifest file with a couple of properties specified. So we'll see an example of packaging in a little bit when we talk about an actual demo of the Java agent and how to create that using build tools that developers typically use. And after that, you will need to specify the Java agent parameter, and you will need to point both to the jar file that is a Java agent and specify the arguments that you would like to pass to the Java agent. So it's a fairly simple jar file that you will create. It can contain any amount of code, so you can go as crazy or as complicated as you would like to. But in a nutshell, to create a very simple Java agent that does one simple thing, you don't have to build enterprise applications or follow thousands of conventions. So let's look at the Java agents more. So why the Java agent technology became possible since Java 5? Because they introduced the Instrumentation API. So when you specify a Java agent, it will receive an instrumentation instance, an instance of the instrumentation class when the pre-main method is executed. And you can use that to do one very special thing. You can register transformers for the class files. So as you know, any Java program contains Java classes, and these classes specify the behavior, what exactly the program does. So a class file transformer is a thing that will receive, at the class loading time, it will receive the bytecode of the classes of your application, and it can modify that or transform it on the fly during the loading. So the dynamic loading of the classes was an amazing thing that made Java the platform that it is today. So we started packaging everything as a pre-built DLL files or something, and started distributing jar files with bytecode that is pre-compiled, but it will be dynamically loaded and linked at the runtime. And at the same time, this enabled us to create transformers to change the behavior of the application without actually changing the source code of the application. So a class file transformer is a very important thing, and it would be most probably the main thing that you will need to use from the Instrumentation API. And how the JVM figures out what classes to execute and what class is a Java agent with the pre-main method, you specify that information in the manifest. So, and when you just run and point the JVM at your jar file, it goes and unloads the manifest, figures out what classes are the agent classes, finds the pre-main method, and executes that. If you fail to do that correctly, or you reference the non-existent class, it will crash with a fairly comprehensive message, error message, better than many error messages. So this is quite simple. The second thing, which is even more impressive about Java agents, that not only you can specify a Java agent at the beginning of time when your JVM starts, but you can attach that later to the running JVM process, and which is fairly cool. You can turn on the agent somewhere in production when you would like, and then it can sit there. Before that, it can sit there. So if you're keen on building a debugger or something, you might want to take this virtual machine agent main approach. The most important parameters in the manifest file, they fairly simple as well, and most probably you will just copy paste that from some example that you found somewhere on Stack Overflow or somewhere on GitHub. But what you need to specify, the agent main class if you use the attach, if you want to attach your agent on the fly. You need to specify the pre-main class so the JVM knows where to give the control flow when the application is loading. You need to specify the boot class path for the Java agent to know, to get access to the code that you've written in it. So you can package everything in there, or you can specify additional boot class paths. And two important properties that you need is if the Java agent is allowed to redefine classes on the fly, and if the Java agent can retransform classes that were already transformed once. So you can chain multiple Java agents, and you can put the class files that are loading through all of them one by one, and then all those tools can work together, possibly, if they are written to do that. If we're looking at a manifest file, then, well, a manifest file is just a text file where just all that information is written in plain text. And this is the example of the manifest from the Durable tool. You can see that there are a bunch of more or less irrelevant stuff that is auto-generated, but those things are as the pre-main class, and if it can redefine the classes, definitely have to be there. So if you just created any jar file and forget the manifest, it will not work, and you will have to debug that. Small example: if you want to attach the Java agent on the fly to the target VM, you will need to, so imagine you have two JVMs, and one of them is running, and the second one creates the Java agent on the fly and attaches to the first one. So the API is super simple, and if you think about this, this is exactly how the picture works. So the green JVM is running, and you want to instrument that on the fly and start retransforming classes in there. So you start another Java process that contains the code for the Java agent, and then you attach using the file, not the file, the process ID. Just you attach it to different, so you inject the code into running JVM. And this is it. This is how the Java agent looks from the above. It's just a simple jar file that contains a bunch of Java code and some specifications in a manifest. Now the important part, now the cool part, now to the Instrumentation API. So Instrumentation API, it's a Java package, Java lang instrument, and most probably you will need to consider two main classes in that package. One of them is the instrumentation, which can give you access to the loaded classes inside your JVM, or give you the values, return your values of the flags if this particular instrumentation is allowed to redefine classes of something. And the most important method is the add transformer, for which you will have to provide class file transformers, which is an interface. And we'll see that in a second. So the instrumentation is an interface. So the implementation of that interface will be provided for you by the JVM, and you don't have to do anything to figure out how to do that. So you just use the API, and most interesting things are the add transformer, as I said, and you can specify if the transformation is final or can be retransformed, and you can eagerly, specifically command the instrumentation to redefine the class definitions that had been loaded before. So using that is fairly simple. We'll look at the code in some time. The class file transformer is an interface that contains a single method, transform, that returns an array of bytes. That array of bytes, as you can probably have guessed already, is the actual bytes of the new class that should be loaded. So the class file transformer sits between the bytes that JVM finds somewhere in your file system and tries to load, and between the actual bytes of the class file that will be loaded. So you receive the class file buffer, which is the definition of the class that you've seen before, and you know the class loader that is trying to load the class, and you have the class name for the class, so you can filter if you would like to transform this particular class this way or that way, and it's pretty simple stuff. So an implementation of the class file transformer could look something like this, and it's quite a bit of code, but if we can try to condense that into the important part, so you implement the class file transformer, and then you just work somehow on the class file buffer to modify that. So if you use a library, something like JavaAssist, or what's another one, ASM, you will just modify that class file buffer directly. In this session, we'll look at ByteBuddy, which takes a little bit different approach to creating Java agents, and that is that approach is more fun, and I like it more. So whatever you specify inside the class file transformer and what classes you would like to use, their util classes or other interfaces, it's entirely up to your imagination. So, but you have to provide this in the class file transformer form. So if you imagine the instrumentation there and the class loading process being at the right, you can register multiple class file transformers, and they can all intercept the class loading process, and every one of them can add a little bit or remove a little bit or somehow modify the behavior of the program. So if you consider the example that we looked at before, if you want to build a small tracer for all the methods, it's fairly simple. One class file transformer can add logging statements at the beginning of every method. Another class file transformer, if you wish to separate those concerns, can add the log statements to the end. And everything you will do, you will have to modify and work on the Java bytecode. So this is fairly different from the Java source code that we all know and love to create boilerplate classes with. But there are libraries to leverage that. So you don't have to actually manually specify opcode 77, opcode 75, a load, a store, and stuff like that. However, it makes...
Can we configure multiple agents for a single JVM?
So the question was if we can configure multiple agents for the single JVM, and yes, we can configure multiple agents. You just specify Java agent parameters in a row, and in the same order that they were specified, they will be loaded and their code will be executed. So if they register class file transformers, all of them will be executed at the same time, and they can manipulate the same class one after each other. So there is a danger that one of them will create code that is unreadable by the other one, or there is a danger that you will, say, make incompatible changes and then everything will break, or it will explode, or it will just silently ignore what you want to do. But that is definitely possible.
Yeah, we have an agent to emit metrics, and we have an APM agent from directors. Thanks for finding out.
Cool. Thank you. So the comment was that it is indeed possible, and the experience shows that it is possible. So.
No, I don't know it is possible. We are trying now.
Oh, yeah, it is possible. It is possible. Definitely should be possible. So back to the bytecode. The JVM is a stack machine. So somewhere in the JVM there is a stack of instructions, and the bytecode works on those individual instructions. And you can add values on the stack or execute the operations. And this is a fairly low-level thing that was created, and it's very efficient for the machines to read and execute and understand and interpret. But it's really uncomfortable for human beings to think about creating programs on that level. So if you have experience with assembly, for example, you know that writing large programs that do complex enterprise business logic in assembly is a very challenging task. So Java bytecode is way higher than the assembly, or a little bit higher than the assembly, but it's not something that you would like create programs in. So what you want to do, you want to actually use some kind of library. And in the past, I've been talking about how to manipulate the Java bytecode, and one of my favorite things was Java Assist. This is a library also under the JBoss, and the best thing about Java Assist is that it provides you the source level API. So you can use your Java code, and you just specify your Java code in a string. Basically, you can write quotes and then Java code and quotes, and the Java Assist will compile that on the fly during the runtime, and you can add stuff like that, add code on the fly using plain Java language. But then with some experience in that, I realized that that's not the best approach, because a stringly type language where you just write everything in a string with no IDE support or anything, it's kind of like a quickly growing into a big mess when you add code. So imagine just having no compiler support until the runtime, and you have to write all the Java code. Imagine having very mysterious error messages when you forget to add a semicolon, which you will forget to add because there is no IDE support for writing Java in a string. But this is probably the easiest way to manipulate the bytecode, and it doesn't require any paradigm shift in your mind. However, more recently, I started to like ByteBuddy much more. So ByteBuddy is a code generation library, and it was specifically created at first to create Java classes at the runtime and without the help of the Java C compiler. So if you know there is the ability, you can create proxy classes at runtime, and the support for that is inside the JDK. But proxies you will be able to implement the interfaces, and ByteBuddy will allow you to create arbitrary classes, and it contains a very nice DSL, type-safe DSL for writing out classes using bytecode. And ByteBuddy then grew for a couple of years, and last year it received the Duke Choice Award, and many applications currently that use Java Agent try to either already moved from other bytecode manipulation libraries towards ByteBuddy or consider moving. So Raphael Winterhalter is the main author of the ByteBuddy, and he's a good friend of mine from Oslo, Norway. And his idea when he started devising ByteBuddy, one of the main goals of the functionality was to create an API that is as non-intrusive as possible and that does not leave any traces of itself in the classes that it generates. So imagine you generate a class and you have the compiled output. So ByteBuddy makes a really good effort at not leaving any marks that this class is actually generated by ByteBuddy and not compiled from Java source code as you would do normally, or not created as by you by hand. So the benefit of that is that you can use those classes at runtime without ByteBuddy being on a class path. So you just can use them as typical class files, and together with the type-safe DSL and the incredible API for manipulation of bytecode and classes, it made ByteBuddy amazing. And also this non-intrusiveness inspired the logo to be a ghost, which comes and you see that, but then it goes away and you don't see that. And now we are ready to look at the actual implementation of a Java agent and how to build one. So while I'm trying to switch to the mirror mode, we can maybe have a question if you have one. Do you have a question? No? Good. I'll try to. Oh, come on. Mirror mode. Arrangement. Mirror displays. You can see that, right? Let me Try to make it a little larger. So this is incorrect. We'll see why it doesn't compile. So I have a small project called CallSpy here in the Eclipse, and this is a project. The code source for that is available on GitHub, so if you would like to check that later, it is possible. So this Java agent that we'll try to build here will be doing exactly what we wanted. We'll be printing stuff when we enter the method and printing stuff when we're leaving the method. So you can see that it uses Gradle. What you need to do to create a Java agent, you will need to somehow figure out the dependency that you will use for the bytecode manipulation. And, well, it's fairly easy. Both Java Assistant, ByteBuddy, and all the rest are available through the normal Gradle Maven repositories. And then the important part was the manifest. If you remember, we talked that you actually absolutely have to have the manifest in the jar file that is your Java agent, and that you have to specify properties. So you can see in Gradle, you specify the manifest as easy, well, in this easy way. And the important bit is here that we specify the pre-main class, the class that will receive the control when we start this as a Java agent. And we say that, oh, you know what? We want to have the ultimate power on the JVM, and we want to be able to change the bytecode of any class that goes through the loading mechanism. So building this is fairly simple. And after that, we'll need to use ByteBuddy to do things. So let's see how ByteBuddy helps you create classes and types at the runtime. So the API is super simple. What you create, you need to create a new ByteBuddy. And think about this, a ByteBuddy is a body of the class that you want to create or implement. Then you have to specify all the things that you will specify normally in the source code of the Java file. If you think of the Java file, it has, you start with class X extends something, or the default extension superclass would be the object, and then you implement the interfaces, and then you say, oh, there will be methods, and then you have fields. And ByteBuddy allows you to use Java level API to do that. So we create and we say, oh, we would like to have a class that is a dynamic type, and we want it to be a subclass of the object. Then you see that you just, in a very type-safe manner, you reference the existing classes, and you get the whole full support of the IDE if you want that on the implementing that. And then we would like that class that we are dynamic type creating. We want to say that, well, when we access the toString method of that class, and we know that there is a toString method because any class extends an object, and the toString method comes from the object itself. So for the methods that are named toString, which is a single method, please intercept that method and return the fixed value of the hello world back. So create a method called toString that returns a single value. Then you say, make this class, and you load that class as you would load any class into the JVM using some sort of class loader, and you can receive a dynamic type. So now with this small code, hopefully when I will print out the new instance of this dynamic type, I will not receive the unintelligible hash number something as I could, but I would get the hello world. So what I have to do, I have to execute this. Save files, yes. And you see that there is hello world right here. We can do hello world Java 1, so you see that there is no trickery going on, and this class is actually dynamically created. Deselect all, don't do that. So, and indeed, the new class is loaded. So if we just try to print out the dynamic type, this is very interesting. So is this an actual class, or is this something? Oh, I'm not sure what's happening here. I'm really sorry about this. So you can see that the class that we created is the ByteBuddy class and resides in the ByteBuddy package that extends the object, and it's just some random unintelligible class sitting somewhere. But it's indeed not a class that we loaded somewhere from source or from a class file, but this is the class that we created dynamically. Returning fixed values is probably not the most interesting thing here, so I will comment this out and I will show you a different example. This is a way more interesting example because what you want to do, you don't want to specify the code, hard-code it somewhere, but you want to use the normally written classes that you create, and you want to use the code from there at runtime. So the difference between this example and the previous is that when we intercept, instead of just returning some value that we have, we delegate. And we delegate that to the hello world class. So all the rest in this example is the same, except for this method delegation thing. So if we look at the hello world class, we just have a single method called intercept. And when basically what ByteBuddy does, ByteBuddy figures out that when the toString method is called, we should execute the code in the hello world class. So if you think that when we run this, the different hello world will show, then you're probably true. You're probably correct. The problem persists. You can see that there is an intercepted hello world. Now, this is more like a proper application. We use multiple classes. So if we would like to create logic at the runtime, we could just create a normal class and then refer to that class at the runtime. What is even better, and I'm sorry about this because probably it will throw this dialog at us again, but what you can do, you can have the conditional interception. So the same example as before, or not the conditional interception, but much more interesting interception strategy. So the example is the same as before, but we just use a different class here. So if we look at that, we have the same intercept method, but we provide method parameters to that. So this is one of the things that is amazing about the ByteBuddy. It uses annotations and the type annotations on the parameters to provide particular and inject particular arguments into the parameters of the method you call. So the origin for the method for the thing here, we want to have the access to the method that was intercepted. And this is very important that we not only we just can execute the code dynamically and load the code dynamically in the JVM and create that at runtime, but we also want to tie that as strictly as possible to the code that is in the application and use some types or some information about what we're actually intercepting or transforming in our code. Because of that, well, we can make different decisions what we want to do. So if we run this third piece of this amazing program here, you would see what we would expect. We would expect the intercepted, we would expect the hello world from, and then the method name of the method intercepted. So that should be the toString method. We intercept the toString, and the information about that method will come into our origin hello world class. Stupidity of Eclipse. And indeed, we see that. What do we see? Where's console? We see that the intercepted hello world from string has been given to us, and we can do more things with that. We can, on that method, this is the normal just Java lang reflect method. We can say get declaring class and get the ability to see what class we are intercepting. And you see that the method was declared in the object because it was, and then it was inherited. So ByteBuddy provides you, the reason for this example to be here is that ByteBuddy provides you the API that mirrors what you would do with the class file on the source code level and gives you a type-safe way to manipulate that. Not only just like create and manipulate and write bytecodes, but actually very easy way to refer to the actual code, Java code that you have somewhere, and use that inside the Java agent. So now, when we're a little bit accustomed with the ByteBuddy, let me just delete this class. I don't like it. We'll delete it. Shouldn't be there. Amazing. Now we are ready to look at the actual Java agent, that is the agent that will do the call loading, call tracing. So as we remember from the manifest here, we have to look at the pre-main class, and that would be our agent. If we look at the agent, it's just a public class that declares the pre-main method with the specified arguments that follows the specification, that follows the convention how to create Java agents. And then we just execute a couple of lines of code, and then we create the ByteBuddy agent. So the ByteBuddy allows you to simplify the transformation logic with a DSL of sorts. So if we just want to create the agent builder, we will look at the creation in a second. But we create the agent builder that is a ByteBuddy's class, and we install that agent builder onto the Instrumentation API. So it will take care of registering the correct transformers, class file transformers for you, and you just need to take care of writing the logic of the actual transformation using the ByteBuddy DSL. So if we look at the create agent builder here, that takes the instrumentation. Why does it take an instrumentation? Not sure. So we just use the API and we say we want all the default strategies, and luckily enough, ByteBuddy comes with a very reasonable set of the default strategies. And we say that we would like to transform some classes, and we would like to transform classes for types that match the certain element matcher that we give. So one of the most important element matchers for types would be that you want to instrument just a part of your application. So probably you don't want to redefine the classes of the JDK itself, and probably you don't want to mess with the classes of your Java agent when they're loaded. So you filter what you want to work on, and then you say how to transform a class, and ByteBuddy provides you with an advice API. And advice is something that will give a life cycle, provide and implement the life cycle for the methods instrumentations. So we just say, oh, we want to create advice, and we'll reference my advice class, and we would like to impose that transformations on all the members. So this would be another matcher that says that for any method that we are trying to, we are asking if we should instrument that or not, we should instrument. So if you would do something like this that requires just adding code around the methods or before the methods, then you would just need to create a proper advice. And you can see that advice class is super simple, fairly simple. It comes with the annotations, and you've seen that ByteBuddy makes an excellent use of annotations. So you just have a couple of static methods, and you mark them that, oh, the enter method, I would like to specify when the code is entering the method. And it can have access to the class that is instrumented, and it can have the access to the method name of the method. And currently we will just increase we'll use the stack class. This is a very simple class. We'll increase the indentation that we will use for the logging, and we will print out the actual class name and the method name that is entered. And at the same time, when we exit the method, we would like to decrease the indentation. So when we run a Java program with this Java agent, we would like to just create a nice tree of the invocations. So after that, after you have all that ready, or you downloaded this from GitHub and built your own Java agent, what you need to do, you just need to, oh boy, where's my Gradle? You need to build this with the Gradle, and then you will have the jar file that you add as a Java agent to your Java process. So we just say Java agent, Java, Java agent. So if we call some kind of class that is available somewhere, you will see that it indeed prints a tree of all kinds of methods that just call each other. I can show you the source for that. It's not that particular interesting. I just calls methods on two sample classes, B and A, and they call the methods back through the extension mechanism, B and A. So, but the thing is, every time we transformed, you can see that when the Java agent run, we see that it can indeed transform the classes. And then when the JVM started loading the class random class colon things, we intercepted that class loading process and we instrumented that. And you can see that immediately after that, the new code with the logging tracing statements was there. And then at some point later, when the JVM started loading the classes B and A, we intercepted that as well. So this example shows both the laziness of the dynamic loading the JVM gives and how this particular Java agent works. So now, having this code, you can very easily extend that to do whatever you would like. For example, you can take the timings, how much a method has taken, the execution of certain method has taken, because instead of just printing out stuff, you can store the timestamp and then subtract that from the current time on the method exit, or you can send a text message to the boss when some inappropriate API has been touched, or you can do whatever your imagination requires. So yeah, this was the example of the code. ByteBuddy provides you with a very nice DSL. It provides you with a set of annotations that you can use to do almost whatever you want to. Raphael releases new versions of that frequently. It always has the support for the upcoming Java versions. So I think currently it has Java 9 support baking up as Java 9 is being baked up in the process as well. And it has great documentation. So if you look for the class file or bytecode manipulation library, ByteBuddy is probably the good way to go. I know that Makito has recently changed to using ByteBuddy from whatever they were using before. So if we just go back to the presentation. Do you have any questions about the code?
How hard is it to undo the transformations?
So the question is how hard to undo the transformations. The transformations, to undo the transformation, you have to literally do a little bit less than nothing. So if to enable the transformations, which will happen at the runtime, you have to specify the Java agent parameter on your command line. So if you omit that, then your application will be loaded as usually, and it will not receive any transformations.
But if I've already made transformations, I have to restart the JVM.
To undo the transformations. The question, if you have, so the question is to undo the transformation at a given runtime inside a given Java process, if that's hard or not. You will need to. Yeah, I think it's harder than to create the transformations initially, especially if you have multiple Java agents running at the same time. So you store the initial class files. You can store them, right? So you still have access to them. And you can call the instrumentation redefine and say, now I want those classes to be this again. And that is possible. And that is actually quite easy, yes. But undoing the transformations in the sense that, oh, we modified this bit and then that bit, and going back through all the changes again is not as easy. So, for example, if you think about that, adding code to the beginning and the end of every method is easy because you say, slap something on top, add something from the bottom. When you want to delete that and you just have like a code that is given to you as just a bytecode, then figuring out, oh, I have to delete just those instructions is much harder. But if you have access to the original class files, that should be pretty easy.
Yeah. Then if there are many class transformers, several, then if you redefine the class, they won't be called, I guess. If you redefine the class with the bytecode that is in the class files.
The question is if there are transformers registered and if you redefine the class, the transformers will be called again. That's a good point, actually. So what you will have to do, you will have your transformer to be the last in the chain, and just have the last word that, oh, this is the class files again. And you can do that by saying that, oh, after this transform, please do not retransform the classes, and then the JVM will put that at the end of the transformers chain. I think, at least I think it does so. So, we have another question.
Can the agents know about each other, and transformers know about each other?
Well, can the transformers and agent know about each other? That's a great question. You have to make sure that they do. So officially, there is no API that will say, oh, am I the first Java agent? Am I the second one? But you will receive the classes, and you can query the runtime and say, oh, is this class present? Just as like you would usually do. And you know if that class is present, then most probably the class has been transformed. Or you will have to like set markers, I don't know, add a field that I'm JRebel and I have transformed this class and now it's transformed. And then you will have to make sure that different tools work together. And but you can do all kinds of things. And one of the best things about that is, well, first you have, one of the best use for the Java agents is to provide seamless integrations with the frameworks and libraries that are already there. So when you don't have the chance to modify the code yourself, but you still have to make sure that it integrates with your application correctly, you can provide that missing functionality and kind of make the library that you don't control to conform to your interfaces or to your idea how the API should be with the Java agent. So for example, at zero to run, what we do, we have to reload the classes at the runtime, and that there is a core thing that makes use of that. But then we have to integrate with all kinds of frameworks and know about their life cycles and things. So for that, we will need to create the plugins that know of the library that we want to transform and know the library of those classes, and then somehow expose that library to the core so they work together well. So in a sense, for the use case of the JRebel, the core knows how to reload classes, and the plugins know how to reload the configuration for the frameworks, and they all work together using a single interface, which is maybe a little bit specific case, but it's a very nice example of when you would use Java agents. So there are two main things. First, when you need to add the functionality to your JVM process without changing the application itself. And second is when you cannot control the application in a sane way. For example, that could be a proprietary, well, probably proprietary source is not the best example because it might be incorrect to do so under the license agreements and everything. But if you cannot control the source of the library, but you want to make it conform to your expectations, you can use Java Agent to add that missing functionality or change that functionality for yourself. And to do that, you will either need to use JavaSys or ByteBuddy, or, well, JRebel currently uses JavaSys for that. Would love probably to make use of ByteBuddy. And you can shape the application without actually changing that. So once you start using Java agents, or once you've written a couple of those, they become a very powerful weapon that you can solve any problem with. So imagine the power, since you are below the application level, you are you can change how the JVM and the application interact, and it gives you an amazing ability to do everything you want. So if something doesn't look right for you and you want to change that, you have the ability to do that on the bytecode level. If there are multiple systems that you want to integrate together and conform to a single interface, I will slap a Java agent on top of that. If you need to find out what classes have been loaded into your JVM and dump their bytecode while they were loading, you can do that using same tools, but you also can create a Java agent for that. And when that power is not enough for you and you're like, oh, I would like to go deeper, there is a really cool thing, you can go native. So there is a Java Virtual Machine tool interface, and together with JNI, and the classes in the instrumentation in Java Lang instrument package, you can create native Java agents that will have much deeper access to the internals of the JVM. You will have to write a little bit of C code or C++ code, not sure, both, probably both. And the thing will go like that. You will have your Java code and you will have your C++ code that implements the agent. And there are, I won't show the code because I'm not very proficient with stars and ampersands and dereferencing operation. But in a nutshell, it goes like that. You have Java code that you want to utilize from your normal Java agent or for your application. And then it makes a GenI call to the C code that makes use of JavaMTI interface that can do a lot of stuff for you. So if you are a Java developer, this can be simplified into you have your Java code, and then there are things that you have to do, probably following the tutorials or documentation, and simplify the C code to the minimal. And the benefits of going native is that you get really cool operations that you can do. You get access to threads, so you can stop any threads or thread groups. You can count threads. So if you ever imagine that you would need to count threads, and you're like, oh, let me just use thread get all stack traces dot lengths, and you're like, oh, I have that many threads in my JVM running. No, you are not correct. Those are your application threads. So if you count them through the native agent, you will get the garbage collection threads and other things listed there, which is a cool bit of information. You will get the heap operations, which is the mind-blowing power. You will be able to iterate the heap. You will be able to find all the objects of the given class. Obviously, that has the performance repercussions, and it might be a little bit slow, especially on larger heaps, but you can do that. And you will have access to the breakpoints. You will get access to monitors and everything through the native. You will definitely have to have some skills at writing C code to make that actually usable. But once you are done that, you can use that from the Java application. And you probably should not go native from the scratch. So probably if the problem is there and you want to try to solve that, you can start thinking, oh, can I solve this with Java code first? And then maybe if you can, then consider a Java agent. And if you really, really can, then you consider going native. But going with this power hammer on every problem would be not the best, probably. So this is it. If you are interested in talking more about Java agents or the tools that use Java agents, you can either find me or Zero Tolerant people by the booth at the expo hall, and you will get free swag, or you can just contact me and find me on the internet and send me a tweet, or you can get the code for the Java agent that we looked here with the Byte Buddy instrumentation going on the GitHub. Thank you. We have 2 minutes and we have a question.
I'm just wondering if you're familiar with the project Lombok. It does kind of do lots of class transformation, but not using Java agent. How is that the case?
So am I familiar with Project Lombok that does also class transformations, but it doesn't use the Java agent, but it does a different thing. Yes, so Lombok is an amazing project that can simplify your Java code, and they use annotations and annotation processing to generate code for you, so you can put annotations in the class or something, or in the fields, and they will generate getters, setters for you. So the code will actually go through the method calling, but you can just use that as a plain thing. And I don't think they are using a Java agent. They generate code during the compilation phase. This is the annotation processing tool inside the compilation process. And it's a very powerful tool as well, but this is at a different step, at the compile time. So a Java agent will generate code at the runtime for you.
Do you know any library to help with native Java agents?
if I know any library to help with native Java agents, I honestly don't know. So we have a quite small native Java agent at work to power JRebel, and I've written a couple of sample Java agents native, but I don't know any library for that. Probably it has to be like in C, and I'm not very familiar with that ecosystem. But if you want to start, and probably you want to start small, it's a fairly simple. There is a convention that what functions you want to create, and there is a convention what parameters they take, and the documentation is reasonable. So even not very experienced in C person like I could make sense of that. So probably you have to do that yourself, or this is a great thing to try if you want to contribute to open source. Sorry.
Sometimes I would like that the agent uses some third-party libraries. Let's say I want to, whatever, doesn't really matter. So I want to have somebody else's code used in my agent. How do you deal with this?
So the question.
JVM is not having this code, I mean, this class is running. So how are you dealing with this boot class part? The manager is doing something with it, you don't.
Yes, so if the question is how you would make your Java agent to use the third-party code from a library. So for example, I don't know, yeah, you want to create network calls or something and you would like to use that from your Java agent. So you have, Java agent is not, it doesn't get the access by default to the, well, it doesn't use the classes from your application or from your class path, because typically when you want to load those classes, you want to transform them. So what you want to do, you want to load classes from a different source and not transform them to use them yourself to transform other classes. So there are two main things how to do that. Either you would like to specify the boot class path that will be provided and it will serve as a class path to the Java agent as well. Or what you want to do, and the boot class path would be initialized for the Java agent. Or what you're going to do, you're going to shade and shadow repackage the dependencies that you want to use inside your Java agent.
Do you know what is better approach?
I think, personally, I think messing with the boot class path is not a very good idea. So I would repackage everything. And many tools that do repackage. So for example, ByteBuddy uses the ASM. And I think ByteBuddy repackages ASM to include that as a dependency. So it's just a couple of lines of code in your build script, and it works fairly well. And then you separate yourself completely from the application, which allows you to kind of avoid very hard to find and fix bugs. Yeah. Yep. Thank you for coming. Find me on Twitter and talk to me.